Hi everyone, welcome to Unshackling Sudokus and Puzzles. I'm Kishore, and today I'm going to solve a hybrid Sudoku titled ISO, and this Sudoku was created by ICHTUES. So it has been taken from Logic Master's Germany portal, and the Sudoku has been rated 97% on the portal and has been received very well in general. So if you want to give the Sudoku a try yourself, the link to solve is given in the description of the video. Please do give it a try and come back and watch the video. It's a standard Killer Arrow Sudoku. So I'll just read out the rules. Normal rules apply. In cages, digits must sum to the small digit in the top left corner of the cage. So killer rules, you consider a cage and add all these digits, you will get the clue given in the top left corner, and digits do not repeat inside cages. Then arrow rules apply. So in all these circles where you have some arrows coming outside, the sum of the digits will be equal to the digit in the arrow, and digits may repeat along an arrow, unlike a killer cage where you can't have repeating digits inside cages. In an arrow you can have repeating digits. For example, this is a single cell arrow, so both of these can be the same digit. So as long as rules permit, you can have repeating digits along an arrow. So these are the rules of the Sudoku, and with that I'm going to give this Sudoku a try. Hope you enjoy this video. Okay, so how do we start? These are some really good places. I mean, these two circles, because they are 3 cell arrows, and the minimum sum of any of 3 digits will always be 6, 7, 8 and 9. I'm sorry, the minimum sum is always going to be 1, 2 and 3. So which means that the minimum digit that gets into the circle is a 6 and above. And similarly, this will also be a 6, 7, 8 and 9. And by the way, this is a live solve. So 3, 4, 5, 6, 7. Okay. This 37 cage has 7 digits which add up to 37. And we know that digits do not repeat inside cages. So we need to isolate 2 digits which add up to 8. And why is that? Because the sum of 9 digits in a Sudoku, 9 distinct digits from 1 to 9, will always be 45. So we have 7 of those digits inside this cage. So which means we need to exclude 2 digits which add up to 8, so that we reach 37. And look at this cage. This is also interesting. 1, 2, 3, 4, 5, 6 and 7 and 8. So 8 cells inside the cage, which means we need to exclude a single digit which would be 8. So 8 cannot be in any of these cells. That is fantastic, right? Because if you have an 8, you can never remove a digit, a single digit, and then get to 37 from 45, right? So which means 8 in this row, that is row 4, must be in one of these cells. So if the 8 goes in the arrow, this becomes a 9, and if the 8 remains here, it would be as it is. So this circle can only be 8 or 9. It can be nothing else, right? So now let's look at maybe 41. It looks really helpful. So 1, 2, 3, 4, 5, 6, 7. You have 7 cells inside the 41 cage. So which means we need to remove 2 digits which add up to a 4, and that can be made only one way, 1 plus 3. So which means 1 and 3 must be in these 3 cells in row 1. And obviously 1 cannot be in a circle because you can't have 2 digits that add up to 1. So let's see what gets into this circle. If you don't have 3 also here, this goes on the arrow 1 and 3, and this becomes a 4. And if 3 gets here, this would be a 3. So this can only be 3 and 4. And which means if it's a 3, this becomes 1 plus 2. And if it is a 4, this becomes 1 plus 3. So these are the only digits which can get inside this arrow and this arrow stem, right? Now let's look at the Sudoku again. Okay, this cannot be a 6. And why is that the case? If this is 6, we instantly know that we need to put 1, 2, 3 here. That's the only way to get 6 from 3 cells. and which means that, okay, forget what I said. That wasn't right. That wasn't right. I actually assumed something wrong. So okay, so in row 1 we have 1 and 3 here. I mean, if you look at these three cells, where, and if you look at row 1 in total and ask yourself where does 5, 6, 7, 8, 9 go, it must be inside these 6 cells, right? 5, 6, 7, 8 and 9, which means this cell cannot be 5, 6, 7, 8, 9, and of course it cannot be 1 and 3 because 1, 3 cannot go inside 41 kg. So this can only be 2 and 4. So we have reduced this cell to a bi-value candidate. I haven't looked at this 36 kg. 1, 2, 3, 4, 5, 6. So 3 cells which sum up to 9 must be removed from this, removed from 45, right? So let us remember that. I'm just thinking here how exactly to continue because the next step is not so apparent. 6, 7. Does that have to do with this arrow? What happens if this is a 9? So you get 1 plus 8 here, and this arrow needs to take all digits except 8. So 1 and 9 would go here, and there's no problem with that. Okay, this is kind of tough. So do these arrows do anything? 1, 2, 3, 4. They take up totally 4 cells in box 8. So which means that if you add these two circles, they must be minimum 10, because the sum of 4 digits minimum would be 10. Okay, do we have something here? Look at these things in total, and by these things I mean all the highlighted cells. So what have we got here? We have a killer cage which adds up to 36. We have an arrow circle which is running this way, and we also have another arrow circle which is running this way. Can we use some arithmetic here? So we know that this box in total, box 8 would sum up to 45. Let me highlight that in red. So okay, let's see. This was the first set that we took, and by set I mean collection of boxes or rows and columns. So consider these cells as the first set, and from that set we don't know the sum of these set, right? uh, let me see. What I'm trying to do here is I want to add all these together and subtract 45 from here. So if I do that, um, okay, that is not so helpful, I think, unless we get some values here or maybe here. I don't see how that would be helpful now. Ah, let's call this A, the digit in the circle. Let's call this B. And now we know that the sum of the yellow cells would be equal to 36 plus A plus B. and from that set I'm subtracting this box, right, which sums up to 45. So a plus b must be equal to 9, right? Is that how can that be possible now? What am I doing? 36 plus a plus b. Okay, I need to say 2a plus b, right? What is the sum of the digits in the yellow cells? This arrow, this circle is going this way. So we can say that this would be 2a. If you consider the digit in the circle as a, the sum of these entire cells, I'll use a different color, must be 2a. The sum of the green things would be 2a, and the sum of the red would be 2b. Let's assume you have a b here, so this would be 2b. And now let's add the yellow one. So let's add all these together. We have 2a, we have 2b, and we have 36. So 36 plus 2a plus 2b, that's what we have on the left side of the equation. Now let's subtract box 8 from that. Box 8 sums up to 45. So we can get what is 2a plus 2b. 2a plus 2b is equal to 45 minus 36. Oh, this can't be possible. What am I doing wrong? Because I'm getting 2a plus 2b as equal to 9. That is never possible, right? Because it should be even. I'm not sure what I'm doing wrong. Let's say we have a in here. Let's say we have b in here. Two a plus 2b plus 36. And if I subtract 45 from that, I should be getting the sum of these three circles, these three cells, which would be a plus b plus this cell. And we don't know what is this cell. Oh, this is tough, guys. A tough one. And I'm not sure I'm making use of the arithmetic in the proper way. Let's see. Although I think the break-in must be there. For some reason I'm not able to see what exactly needs to be done there. I think this has to do something with sets. How exactly do I make use of that is the question. Or do we have something here? I'm too focused on this area that I'm not looking at other areas. Sorry for this. Unable to see anything here. 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. I'm sure that these are not going to help now. This must be the area that gives something, right? Okay, let's see if we can start eliminating the values here. This may be a crude approach. I'm not seeing anything how to continue. So let's say we have 9 here. So this area sums up to 20, how much is that? 27, right? So which means these two sum up to 18. I mean this area must sum up to 18, which indirectly means the red and the green cell must sum up to 18. So that's not possible. So 9 is eliminated. And if I have an 8, so this sums up to 28, the yellow area. So this sums up to 45 minus 28, which is 17. So these must be 8 and 9. But 8 is already here. We start with 8, right? So 8 and 9 is also ruled out. So 8 is ruled out. We ruled out the 9 already. So can only be 1, 2, 3, 4, 5, 6, 7. Can this be a 1? So this would be 35. So this would be 10. And these two cells must sum up to 10, which is possible. If this is 2, 34, 11. These would sum up to 11. Again possible. Okay. If this is 3, this would be 33, 12. And these two would sum up to 15. What am I doing? 33, 12, 12. These would sum up to 12. So they would increase one by one. If this is 4, this would be 13, 5, 14, 6, 15, and 7 would be 16. Okay, 7 cannot be possible. Let's say you have a 7 here. Then this must sum up to a 29. So which means these 4 cells sum up to 16. And you would require a 7, 9 here. But we already started with the 7. So 7 is ruled out. So I can get this only to this much. 1, 2, 3, 4, 5, and 6. Oops. Start is so hard here. Very hard start. But I'm enjoying this. Let me check. If we get the start, I think we should be able to get a lot of digits. Can we do something here? Why is the 8 here? We could have eliminated it ages back. So this can only be 6, 7, 9 because we have an 8 here. 9, 1, 8. If you have a 9 here, this would be 6, 7. So 1 goes here. 1 goes here. 9. This would be 2, 3, 4. 36. 1, 2, 6. Ooh. Oh my goodness. This is unbelievable, guys. Unbelievable. What a start. I've been focusing so much in this area that I almost forgot that look at these boxes, guys. Awesome. You'll notice that these cages and this arrow taken together occupy these boxes in totality, right? So we can make use of that. Awesome. So let me highlight that in blue. So we can get the values here, and that I think should be the break-in. I don't see anything else how we could break in, because this area yielded us nothing except some useless digits, 6 digits. So box 1 and box 2 add up to 90. 45 plus 45, 90. For some reason I'm calculating the total slowly today. So let me use a different color here. Big dark here. Okay. So and we know that the sum of this and this is equal to 72. 41 plus 31 is 72. So if you have a 6 here, this becomes 12. Totally, the total of this element becomes 12. So 72 plus 12 would be 84, and this would be a 6. But can you have a 6 and a 6? Not possible, right? 72 plus 6 is 78, and this would be 6 again, which is 84. And we know that these two boxes sum up to 90. So 90 minus 84 gives you a 6 here again. So this can never be a 6. Awesome. So can this be a 7? If you have 7, the sum of this element becomes 14, and we know that these two add up to 72. So 72 plus 14 would be 86. So this would be a 4, which is again not possible. And why is that? When you have a 7, this instantly becomes 1, 2, and 4, right? So that is not possible. Awesome. So we have a clash of digits. So that's not a 7. So let's say we have an 8 here. So the sum of this element will be 16. 16 plus 72 would be 88. So that would be a 2. And that I think is possible. Because if you have 8 here and a 2 here, so these would be a 134, right? And which is certainly possible. Okay. So we'll remember that for now. This is one of the possibilities. 7 is removed already. So if we have a 9 here, the sum of this element would be 18. 18 plus 72 is 90. Okay, that's not possible. So this has to be 8. Superb start. What a start. What a start really. Excellent. ICHTUES, superb. This is amazing. Really good. So you cannot have 9 here because the sum of this element would be 18, and 18 plus 72 is already getting you to 90, but you have one more cell. So if you have any digit here, the total of these two boxes will become more than 90. So this has to be 8, and that would be your first digit in the Sudoku after 21 minutes of solve. Maybe I didn't perform as good as I should have done. So this would be 8. This has to be 2 as we saw already. So this would be a 134. This is a fantastic start, guys. Awesome. Beautiful grouping logic there. I got the right idea to use the grouping logic, but I was looking at the wrong place. So this served as a red herring. So this is the place to start. That becomes a 4 now. And now we know what is the composition of this arrow. 4 gets pushed here and that becomes 1 and 3. So we have a 1 3 here, we have 1 3 here. That gives a 1 3 pair here. I think this cage can be made use of now because we got 2 digits already. Maybe even this arrow. So you have a 2 in row 3. So 2 goes in these 3 cells. Can't be in a circle. So 2 must be in one of these cells. Let's see what goes here. It could be 2 plus 5 and 7. It could be 2 plus 6 and 8. Or it could be 2 plus 7 and 9. Right. So this can only be 2, 5, 6, 7. Right. Yeah. You have 1, 3, 4 here. So this can only be 2 plus 5, 2 plus 6, 2 plus 7. Yes. Now let's look at this cage and see if we can get the rest of the digits. So we need to remove, this is a 6 cell cage. We need to remove 3 digits which sum up to 45 minus 31, which is 14. So 3 digits which sum up to 14, and 2 is already one of them. So we need 2 more digits which sum up to 12. 2 more digits which sum up to 12, and that cannot be 3 9 because 3 is already in the cage, and that would have to be a 4 8. Awesome. This is fantastic, guys. So from this cage we have to remove 2 plus 4 plus 8 because 4 is already outside the cage. You can see that this cage can never take a 4 because of this 4, and 2 is already outside, as you can see. So which means one more digit which we would need is an 8. So 2 4 8 are not inside, so rest of the digits are inside. This would be 5 6 7 9. Fantastic, guys. Amazing. So what do I do now? So and in this box 2 and 8 must go in these 3 cells. No other place left now. Okay, now this cannot be a 9. Superb. Fantastic. So if this is 9, we know that this instantly becomes 1 and 8. Right? This instantly becomes 1 and 8. And we know that this cage contains all digits except 8. So if you have 9, 1, 8 combination here, where do you put the 1 and 9 inside this cage? Not possible. So this has to be taking the 8 here. And now this we know that cannot be 1 plus 7 because we don't have space for 1 and 7. Cannot be 3 plus 5 because we don't have space for 3 plus 5. It would have to be a combination which has the 2 in it to be a 2 6. That becomes a 6. Now this is not 6, so that's 7 and 9. So if it is 7, this would be a 2 1 4. And if it is a 9, it cannot be 1 2 6. It can be 1 3 5 or 2 3 4. Okay, lots of possibilities there. where do I go now? I really hope that this is 7 because that would give us a lot of digits. 7, 2, 1, 4. 1, 2, 4, 6 and 7. So this becomes 3, 5, 8 and 9. 5, 8, 9 is 22 and plus 3 is 25. So these sum up to 12. That is possible. So we notice that this cage has to remove 2 digits which sum up to 8. That I think not helping now. Okay, again some weird combination of boxes and rows is in play perhaps. Not certain how to continue here. This cage has to come into place somehow, guys. This has to be activated somehow. Let's say we have a 7 here, so this becomes 1, 2, 4. So this would be 14 in total and this would be 20. This would be 25, so this would be 12. Suppose if this is 9, this becomes 18, this becomes 24, so this would be 21 and this would be 16. So the sum of these three cells is either 14 or 16 and both are not so helpful numbers. Both are not so helpful numbers. So okay, let's use some classic here. So 6 must be in one of these three cells. Let's say we have a 6 here. What happens? This would be 30. So this would sum up to 15 and this would be 6 plus 9 or 7 plus 8. Because we have the 6 here, this would be 7 plus 8. Okay. That pushes 7 here. 2, 1, 4, 6, 7, 8, 3, 5, 9, 1, 2, 4. Okay, I went a lot. I went very far ahead, but nothing to be seen. Oof. Tough one. Tough one. Perhaps this area gets activated now. Not sure what exactly needs to be seen here. So this really looks like a juicy spot to see what could be going on, but not helping much. A 7 here instantly gives us a 2 here because this would be 1, 2, 4, but this could also be a 9. That is a big problem. What do we get if we have a 5 here? So this becomes 31 and this would be 14. So this must sum up to, okay, we have a 5 here, this becomes 6 and 8. Yeah, that should be okay, I guess. And if we have a 4 here, 32, 13, we have 6 plus 7. It's also okay. If we have 3 here, this would be 33, this would be 12. And 6 plus 6 is not possible. So this cannot be 3. So if we have a 2 here, this would be 34, this would be 11. This would be 6 plus 5. 2, 5, 6 is okay. If we have 1 here, this is 35. This is 10. So this will 6 plus 4. This would be 6 plus 4. So 1, 4, 6. That is also possible. Okay. I've seen all combinations and eliminated just one. Ah. I'm missing something very simple here. So I know that this box needs to contain 7, 8 and 9. That's the only thing I know. Can we use grouping again here? Maybe some weird way these things are getting combined. I don't see how, because that's for first thing it is extending into three boxes and there are lots of vacant cells. We can't use that in a way that would help us. I haven't looked at this 17 cage at all. Not helpful at all. 1, 3, 4, 7. Okay. How do we continue here? This 37 kg is what is going to help us, I'm certain. Hmm. Okay, so for this cage, yellow cage, we have 36 here, and we need to remove two cells which sum up to a 9, right? So 9 would definitely be inside this box. We can't say the same about 8, right? 9 would definitely be inside this box. So let's see where the 8 goes in box 5. 8 cannot be in row 4. So 8 is in one of these 4 cells. And okay, we can just simply say that this box needs to have 8 in one of these 3 cells, right? For this row, you can see that 8 can only go in these 3 cells. None of the other cells can take an 8. 9, 2, 3, 4, 7, 8, 4, 7, 8. There's something need to see as contradiction here. I'm not able to see that. This area is what I would call a biggest disappointment, because hoping there is something there, doesn't seem to be anything there at all. Sorry for this, guys. I'm totally clueless here. If I ah, very tough step. What is the intended step here? Am I missing any rule part? I think so. This is really embarrassing. This step, what I'm missing here. Okay, let's just look at this arrow and see if we can get something. So this is 7, this would be 2, and this would be 1, 4. And if this is a 9, So it can be 1 3 5. So this can be 3 5. This will also be, oops, sorry, this can be 1 3 5. This will also be 1 3 5, and it also can be 2 3 4. So this would be 2 or 4. This can only be 1 2 3 4 5, right? Yeah, I'll just replace that. This can only be 1 2 3 4 5, and this can be 1 4. Okay, I'll also write that 1 2 3 4 5, nothing else. This cannot be a 2. This would be 1 3 4 5 7 9. Some shortcut here, guys. I'm completely missing that. I'll just see for a few more minutes, and if I'm not able to get anything, I'll probably need to scrap this video. Let's say, let's hope that it doesn't get there. Oh my goodness, I missed a very simple thing, guys. Very simple thing. Really simple thing, guys. This 8 cannot be in row 3, so 8 would have to be forced here. I'm very sorry for this, guys. Very sorry for this. This would have to be 8. So this is a 2 6. That's completely goof up on my part. 2 6 8 1 3 4. So this would be 5 7 9. Why did I miss that? God only knows. So this is 5 7 9 and 1 3 4 5 7 9. So this would be 2 6 8. So 1 3 4 2 6 8. This has to be 5 7 9. No wonder the Sudoku was not budging anywhere. Really a simple and costly miss. So now, okay, now we get to know what are these two digits which are missing from the 37 kg. Superb. So it has to be 2 plus 6, right? Because 6 cannot be in the 37 kg. So 2 cannot be in these cells, and 2 would have to be here. There is no other cell left in that row, so 2 goes here. Now we know that this cannot be 9, because then for the 9, okay, it can be 9. If it's 7, this would be 1 4, and if it is 9, it would be 3 4. So 4 is definitely in here, and this cannot be taking 2 plus 6, so it would have to take the rest. So 4 has to be here. Okay, this cannot be 2, that's 1 4 5 6. This cannot be 2, that's 6 8. 8 goes in these cells using classic, and 5 has to be in these 3 cells for box 6. Okay, where does the 2 go in column 2? There is only one cell left. It has to go here. It cannot be in this cage. It cannot be here because that would repeat digits inside cage. Nothing else can take. So 2 goes in these 3 cells in column 4. Can't be here, can't be here. 2 has to be here. I'll just remove the 8s from here. They are just confusing a bit. Okay, 2 cannot be in the yellow cage completely. So now we know the composition of the yellow cage. The digits which are getting removed must be 2 plus 7. So this would have to take a 2 7 somewhere. 2 7 must go here, and rest of the digits must go inside here. So we know what 2 cells add up to here. The next step, okay, 6 in column 3 must go in here. 8 in box 4 must go in these 3 cells. Okay, you can't have the 8 here because that forces 8 in here and there would be no 8 in row 5. So this cannot be 8, which means 8 must be in these 2 cells and that gives 8 in these 3 cells. So we need to squeeze something outside this area. Okay, this cannot be 2 because that forces 2 here. So that's not a 2. So 2 is in these 3 cells. One, 4, 7, 3, 5, 9, 3, 4, 9, 1, 5, 7. 3, 4, 9, 1, 5, 7. That seems possible. Again stuck. Again stuck. And I hope that I don't miss something simple here. So if I have 6 here, 6 goes with some of these 8. 3. Okay, I can't have the 6 here. Why is that the case? If I have 6 here, the yellow cells must sum up to 30. So which means that this area sums up to 15. So which means that we must have 7 and 8 here because we started with the 6. So this would be 7, 8. But we already know that we have a 2, 7 here. And now 6 in this box must go somewhere in these cells. And it cannot combine with the 7. It would have to combine with the 2. So 2 plus 6 gets us to 8. And we also have a 7. And that cannot map to a 7. I hope I'm clear here. 6 goes inside this area. If 6 goes inside this area, or a simpler way to see is, so when you have 6 here, this would be 30, this would be 15, so this can only be 7 plus 8. Now if you add 2 plus 6 plus 7, we already get 15, but we need one more cell, right? Which there is one more cell in this 4 cell area. So you cannot have 6 here. So 6 would have to be going in these 2 cells. That is certain. So if I have, let's say, a 5 here, so 5 goes in this area, which means, okay, you have 31 from here, so this would be 14. So this would be 14, which would be 6 plus 8. Okay, that seems possible. 6 and 8. Oh, I've completely goofed up the solve here, guys. Completely goofed up the solve. There are 3 digits here which add up to 9, right? Why? I don't know why I'm solving such crazy bad today. Crazy bad. I'm sorry for this, guys. 2 is just one of the digits that is out of this cage, but I assume that there are only 2 digits that we need to remove. This is only a 6 cell cage. We need to remove 2 more digits which add up to 7, which can be okay, let me put all these here. Okay, this would be true, right? So this was only 1 2 3 4 5 6. It cannot be 2, so this is 1 3 4 5 6. Okay, 2 is in this area for sure. The other 2 cells must be 1 plus 6 or 3 plus 4. They cannot, yeah, they must be 1 plus 6 or 3 plus 4. So rest of the digits are inside, which are 7, 8 and 9. They must be inside here. Okay, just remember that now. I'll just remember that. Okay, this can't be 5. We have a 5 here, so this is 1 3 4 and 6. So if this is a 6, 6 goes in here. This is 4. 4 goes in here. So, ah, hmm, very hard to see. Difficult Sudoku for a live solve. I wonder how people do live solves and find things as if there's nothing to it. Really hard, guys. Surely this area must help. There does seem to be nothing there. So if I have 1 here, this would be 35. This sums up to 10. So this becomes 1, 2, 3, 4. Okay, this would be 3, 7 or 4, 6. Okay, 6 was here, right? We have a 6 here. Uh, mm, 3, 4 would be left out. 1, 5, 7, 8, 9. 3, 4 and 6. 7 and 8. 8 has to be here. 7 would be here. 1 and 4 would be here. 5, 8 and 9. 1, 4, 7. Ooh, what is this? A super tough Sudoku. Okay, so let me write the digits that this area contains. This has to have 5, 6, 7, 8, 9, right? Okay, this has to have 5, 7, 8, 9 because 6 can be here. So if you look at this cage in total, 2 is already removed. We need to remove 2 more digits which sum up to 7. That cannot be 2 plus 5. So it's either 1 plus 6 or 3 plus 4. So rest of the digits must be inside. 5, 7, 8, 9 would have to be inside. So which means this area must be 1, 2, 3, 4, 6. So we have 5 digits and we need to remove 1 digit out of that. So it could be this is 1, 2, 3 and 6. I need to need time to think about this. 1, 2, 3, 6, 12. So this is 33. This would be 3. So this would be 12. Be 4 and 8. 4 and 8 seems possible. I'm probably missing something very simple again because Sudoku can't be possibly this much hard. Okay, look at this. This cannot be 2. I eliminated that ages back. This will also be 1, 3, 4, 6 because this is a single cell arrow, so both are going to be the same. This is 1, this is 1, this is 3, this is 3, this is 4, this is 4 and this is 6. This would be 6. Oh, this can't be 8. Oh, again a very sharp deduction. So if I have an 8 here, where does the 8 go in row 5? Tough one to see. So that has to be 8. And now I know this would have to be, look at this row, where does the 5 go? 5 goes in these 3 cells. So these cells are not 5. So 5 is either here or here. Can I put something more inside this cage? Okay, 7 and 9. This is a 1 and 4. One goes here and that would be a 3. This is a 3 and 4. The 4 goes here. 4 is already here. How much time the video has gone? 50 minutes, guys. Close to an hour. And I feel completely useless today. Okay, now that we have put an 8 here in row 1 and row 2, so 8 must be in one of these cells. I hope that helps at least. Okay, that is nice. So now we know where the 6 goes. 6 cannot be in these two cells because if you have 6, 8 here, right, 8 must be in these 3 cells and 8 cannot be here. We have already eliminated 8. So 8 goes in one of these 2 cells. So if 6 also goes in one of these 2 cells, let's say we have 6, 8 pair. So this becomes 14. So this would be 31, this yellow area. So what do we need to have here to get to 36? So this would be 5. And we don't have a 5 there because of the 5 here. So this cannot be 6 also. So this would have to be 6. Finally, the crucial digit. Finally. And I promise the Sudoku is going to get finished now. So if this is 6, this has to be 8. That becomes a 2-6 pair. So now we know this area sums up to 30. So this would be 15 and that has to be 7-8. Finally, guys, sorry for this really yucky solve that I made today, but seriously, I apologize for that. I missed many things. I don't know why. So 7 is removed from this row. So 7 goes here. That becomes 1 and 4. 1, 2, 4, 7, 6, 8. So this would be a 3, 5, 9 and 3, 5, 8, 9. 2 and 6 cannot go here. So this must be 1, 4, 7, right? This must be 1, 4, 7. 7 is already here. So 7 is removed from this cell. So 7 goes here. This is not 7. That's a 5, 9. 1, 2, 4, 7, 8, 6. Okay, this 1, 3 can be resolved. That's 1, that's 3. And for this row, we need a 5, 9 here. 7 in box 4 goes in these 2 cells. Okay, now I know what are these cells. 2, 3, 4 are removed. So 1, 5, 7, 8, 9. 1, 5, 7, 8 and 9. So this would be 2, 3, 4, 6. This would also be a 3, 4, 6. So 2 and 6 and 3 and 4 are the combinations. So this cannot be 6 because that would give you minimum 9. So this is 2, 3, 4. Okay, 8 cannot be in these cells in column 4. So 8 goes in here. That removes 8 from here. So 8 is in one of these cells. That's 8. This would be 1 and this would be 9. Okay, 1 in column 9 has to be in these cells and 1 cannot go here. So 1 goes in one of these 2 cells. This cannot be 1 because if you have 1 here, this has to be 16. So that would be 7, 9. And look at this, these 6 cells in together. 1, 7 and 9. So how do you fill these cells? Not possible. So 1 cannot go here. So that's 1. That's not 1. That's 5, 7, 9. That's not 1. That's 4 and 7. Okay, now you can't have 8 here because then this arrow gets violated. So that's 8. and 8 is removed from here. Okay, 8 is already in these two cells, so 8 goes here in row 7. So we have 17. We also have 9 from these cells. 17 plus 9 is 26. And we need now to get 19 from these 4 cells. We know that this element is even, right? An arrow will always be even. So this would have to be odd, and this can only be 3, 5, 7, 9. And I have not explained why this is odd. That's because we got 19 from the green cells plus this cell. So if this is even, then we need an odd digit here to get to 19, right? So that's why this is 3, 5, 7 and 9. So let's see what can go here. It cannot be 1, 4, 7, 8. 2 and 3 are quickly eliminated, so this is 5, 6, 9. So if this is 5, I have 10 from this area, so this would be 9. So this would be 2, 3, 5, 9, 1 and 8, 4, 6, 7. That seems possible. Okay, this can't be 7 for the column. This is 6, this would be 2, 4, 6, which is 12, so this would be 7. 1, 8, 2, 4, 6, 7. 3, 5, 9. 4 and 6. That's not possible. 6 could be eliminated from here. Because if you have 6 here, this becomes a 2, 4 pair. And now to add up to 19, 2, 4, 6 is 12. So this would be 7. And now what can go here? 1, 8, 2, 4, 6 and 7. So this would be 3, 5, 9. Now look where the 4, 6 gets into this row. In column 1 you have 4 and 6 already. And none of these cells can take a 4, 6. So this cell would have to be simultaneously be both 4 and 6. So 6 is not possible here. So this is 9 or 5, and correspondingly this would be 9, or if this is 9, this would be 18. This is not 9, ruled out. If you have 9 here, you will get 18 from here, and this cell would have to be 1, not possible. So this, because of this 1 here, this is always a 5, and this becomes now not 1 plus 4, 2 plus 3, and now this has to be 10 plus 9. So this is 9, so this would be 4, 6, 7, and that is not 4 and 6, so that's a 3, which gives a 3 here. And to get to 7, we know that 6 would have to go with the 2, so that becomes 8 automatically. 3 would have to go with the 4. This is 4, so that is 7, that is 8. We need 2, 6 pair. So okay, okay, we have 5 here, so this would have to be a 9. That becomes 5, 7, 4, 7, 8, 9, 1 and 5. So this is 6, and a 6 here gives me a 2 here and a 6 here. 2, 4, 7, 8, 9, 1, 5, 6. So this is 3, and 1, 3, 4, 7, 2, 6, 8. So we need 5, 9 pair, and you have 9 here, so that's a 9, that's a 5. That becomes a 1, 4 now. So this 4 can be resolved, so that's a 4, that's a 1, that's 7, that's 1. Okay, so 5 here resolves this 5, 7 pair, and this would be a 4, 7 pair which can be resolved. So that's a 7, that's a 4, that's a 4, that's a 1, that's a 1, that's a 3, that's a 3, that's a 2, and 1, 4, 7, 3, 5, 9. This is 8. I wonder why this arrow is given. It wasn't helpful. Okay, at the start we used that to reduce, right? So that was helpful. And 7 is not here. Okay, 9 is not, this is not 7, 9, so that's a 5. And 2, 6 can be resolved, so that's 2, that's 6. This would have to be 6 for the row. 1, 2, 3, 6, 7, 8. So this is 4 for the box. That becomes 5, 9 because of the 5 here. This is a 9, that is a 5. Now this can be completely resolved. So this is 7. 1, 8 and 9. 8 goes here. So that's 1 and 9. This would be 9 for the column because you have 5, 7 here. That's a 9. That's a 5, 7 pair. 7 is here, so that's a 7, that's a 5. 4 can't go here, 1 and 3, so this 2, so this is 2 and 6, and 9 and 1, that's 1 2 5 6 7 8 and 9, so this would be 3 4, and 5 and 9, so that is 7. Completing column 1, this is 3, this would be 5 9, and this is not 3, that's 5 9, so 7 goes in here. So this 3 gives a 4 here, a 3 here, a 1 here, a 4 here. 2 4 6 8 3 7, so you get a 9 here, a 5 here, a 5 here, a 9, a 1, 9, a 5 and a 3. And that's probably the crappiest solve I've ever made for a video. I would have scrapped this video if not for the time I'd taken. But again, this was not so easy a Sudoku. Hope you guys had some fun at seeing me struggle so much in this Sudoku. I missed several deductions. The first and foremost was missing that the 8 could go in here, and then seeing that 8 can be removed from here, so 8 goes in here. I missed several things here, guys, several things. And towards the later stage of the solve, I got stuck assuming that there are only 2 digits to be removed, but when in actual we removed 3 digits. So if anyone, any person who has watched until this point, then hats off to you. I'm not sure many would have seen until the very end. Anyway, thanks for watching. See you soon again with a video. Bye bye.